Let's look at question number 4. The aluminium bottle, first introduced in 1991 by CCL container for mainly personal and household items such as lotions, has become popular with beverage manufacturers. Besides being lightweight and requiring less packaging, aluminium bottle is required to cool faster and stay cold typically longer than typical glass bottle. A small brewery tests this claim. So they are testing the claim which bottle is getting cold faster, aluminium one or the glass bottle. So they are claiming that aluminium bottle is getting cool faster than the glass bottle. Okay. A small brewery tests this claim and obtains the following information regarding in time required to chill a bottle of beer from room temperature to serving temperature 45 degrees Fahrenheit. Construct and interpret a 19% confidence interval for mean difference. So we need to construct a 90% confidence interval for mean difference. So mu1 minus mu2. Let's say mu1 is for the glass and mu2 is for the aluminium, right? Clear glass versus aluminium. That's what they're asking us to do. So let's see, what do we have? These are two samples. Sample size N1 is 42, N2 is 35. X1 bar is this, and X2 bar is this number. S1 is given 9.9, the standard deviation S2 is given to be 7.3. We need to construct our sample size because these two samples are from two independent populations. So we have, this is independent samples from independent populations. Okay, so that means we are not having the matched pair case, right? And we are testing the means. Okay, N1 is more than 30, N2 is also more than 30. So we sample size is large enough. We do not need to check normality. Okay, what else? N1, although it is more than 30, but it surely is less than 5% of the population size. There is surely many more all bottles, right? All and medium bottles, and N2 will also be less than 5% of the population. So we have independent samples, and it's all already given in the question that they are randomly selected. So that is a random sampling. So all the requirements are verified. If we have all the requirements verified, we can use two sample t interval for this. Why are we using two sample t interval? Because they are independent and we are testing for the mean, right? So the confidence interval is for the difference of means. So we need to use in your calculator, go to stat, go to test, and to sample t interval. You need to know that we are using two sample t interval. So that's at number 0 in your calculator. Sorry about that. Press enter. To two sample t interval. Data is independent and we are given with the stats. Let's go to the stats. Here we are. So let's enter them one at a time. X1 bar is given to be 133.8. S1 is given to be 9.9, N1 is given to be 42. Okay, X2 bar is given to be 92.4, S2 bar is 7.3, N2 is given to be 35. Confidence level is 90%, so 0.90. The data is not pooled, so press calculate and note down your confidence interval. So your 90% confidence interval is 38.129 to 44.671. So what are we saying? What does it mean? This is confidence interval for mu1 minus mu2. Mu1 is for glass and mu2 is for aluminium. We are saying we are 90% confident that mu mu1 is mu glass, if you better understand, minus mu aluminium is lying between 38.129 to 44.671. So what does that mean? So clearly these two numbers are both positive, right? Really large. So the difference between them is really large and positive. That means mu glass minus mu aluminium is positive, clearly, because they are lying between these two numbers. So the difference has to be positive. That means the mean time taken by the glass bottles is more than the mean time to get aluminium bottle to cool down, right? So what does that mean? That aluminium bottles get cooler faster. So there is sufficient evidence to support that aluminium bottles cool faster than glass bottles. Okay, so we can also use confidence interval for testing this way. We are accepting the claim. Okay, this is it for our 11.3. At the end, I'm giving you all this information collectively. This is also written in the call-in formula chart. If you look at chapter 11, you see, if we are testing two means and we are having dependent samples, then we use our t-test on t-interval by calculating the differences in L3. But if we have two means and independent samples, then we use two-sample t-test, okay, and two-sample t-interval if we need to calculate the interval. And if we have two proportions instead for the independent samples, we are going to use two prop C test. So all the information is given in the call-in formula charts. You just need to know how to check those. Okay. So that is it for 11.3. Let me know if you have any questions.